Here we have a triangle ABC and its circumcircle. What else do we have? We have the angle bisectors of all the three vertices. We have AP, which is the angle bisector of angle A, or in other words, it divides A into two equal parts. Then we have BQ, which divides B into two equal parts. And then we have CR, which divides C into two equal parts. What we need to do is prove this result. Just look at this angle. What is this angle? It is QPR. This entire angle. That is what this angle is. And what is this angle? BAC. It is this entire angle. What you have to prove is this result which connects these two angles. So what I will do is, instead of writing it as QPR, why don't I just write it as P? It concerns the whole angle, right? So I will write it as P. Here again, instead of writing it as BAC, why don't I write it as just A? It is the same angle, right? So let us keep it simple. Now in such cases, if you don't know how to proceed, always try reversing the steps. Now if this is your last step, if this is your required result, what do you think the previous step would have been? Why don't we take the LCM, and then this becomes 180 minus angle A. Right? Now, what do we know about angle A? ABC is a triangle. The sum of angles of a triangle is 180 degrees. So, from 180 degrees, if you subtract one of those angles, what do you get? You get angle B plus angle C, right? Why is that? Because angle A plus angle B plus angle C is going to be 180 degrees. So 180 minus angle A is going to be B plus C. Then what do you think happens in the LHS? It is angle P. Now you can see that angle P consists of two parts. Let us break down into those two parts. Then what do you get? It is angle APR plus angle APQ. So here we have hit a dead end. We cannot keep going on in reverse anymore. So let us stop here and prove this result. How are we going to do that? We are going to use the fact that all the angles made by any arc on the same segment are equal to one another. Take the first angle from the LHS, which is APR. This is the angle subtended by the arc AR. Can you think of any other angle that AR subtends? Now you must be wondering what happened to the lines. Too many lines are confusing. So let us concentrate on what we need. You don't even need the illustration to find out what this angle is. What about ACR? Why are we going for ACR? Because we know that AC is a side, so it exists, and CR is an angle bisector, so that also exists. So ACR is an angle. Anyways, we will look at the picture also. So there, if you do not trust me, you can check for yourself. Now let us take the second angle in the LHS. What is that? It is APQ. What is it? It is the angle made by the arc AQ. Can you think of any other angle which AQ makes? Here you can see that BQ is an angle bisector, and you know that AB is a side. So ABQ is a legitimate angle. You know such an angle exists. But let us look at the picture again. So this angle here is APQ, and this angle here is ABQ, and both of them are angles made by the arc AQ. But then what do you know about this angle ABQ? What do we know about BQ? This BQ is an angle bisector of angle B, or in other words, it splits B into two equal parts, or in other words, this is is half of angle B. Similarly, what do you know about this CR here? CR is the angle bisector of angle C, or in other words, it splits angle C into two equal parts, which means this is equal to half of angle C. So now what do we do? Just add these two equations. Then what do you get? So all you have to do is add these two equations, then you will arrive at the required result. Once you reach here, then it is a familiar road. Then you know how to arrive at our original result, the original result that we wanted to prove. So that is all for today. Assalamu alaikum.